questions from last night's homework, so I'm going to do that right now. I'm going to do 3D, and I was asked to do 1 of 14, 17, and 18. I'm just going to do 14, if that's okay. And we'll go through this. So 3D from last night. Go for some of these books. This is any chance?
376.
Okay, this is page 376.
Right, yeah.
Okay, so the question was, verify using properties of the dot product to expand and simplify each of the following.
Hello.
Okay, now. So we had u plus v dot w plus x. So the reason I gave you guys this was just to make sure that we sort of get the basic ideas here for dot product. So what's the rule when you dot? Right. What's the rule when you dot two things with brackets? Like what was, going back to yesterday, I gave you a law that looked something like this. It was something like, I wrote this one on the board. What's the rule for that? Oh. Yeah, go ahead, Jared.
That equals u dot v plus u dot w.
Right on. Okay, so we're just going to do the same thing. So if it's something plus something, remember dot is like multiplying, right? That's what dotting is. So if you have two things multiplied, how do you deal with like two things that you're adding? You with me here, Tana? Please stay with me here today, okay? So let's say that was like x plus 3 times x plus 2. How do we solve that? Foiling, thank you. Good, okay? So we're just going to do the same thing. Okay? So it's going to go u dot w. Because remember, dot is like times in, right? It's like times of vectors. U dot x. And it says answers may vary. That's the only answer that I can come up with for that one.
That was the other one.
Okay.
It was for A and C.
Okay. Because that's the only type of one that I could see. So think of it just like foiling. Remember, dotting is like multiplying, right, Brendan? Okay, so we're just think of it like multiplying. That's all it is. The results are going to be different, right? I mean, it's multiplying to end up with a scalar. That's what it is. Okay. Yeah, go ahead.
U dot u, would you just leave it as so it wasn't going to
U dot u, yeah, it could be like u dot. No, just a reminder. U dot u is remember magnitude u squared. That's what it's going to be. So you could leave it. It would go like that. Okay. Does that somewhat help a little bit? A little bit. That's like magnitude because there's no angle between them. For this, if you're dotting, just think if you're dotting two things and they're in the same direction, and that's u. You guys can talk here for a sec, please. If you're multiplying that times that, again, it doesn't. There's no angle between them, right? So it's just going to be heading in the same direction. That times that. All right, I'm going to do 14. 14 is a little bit complicated here. 14, 17, 18 were the ones that were a little bit difficult from last night. So 14 says, prove each property in question 13 using Cartesian vectors. So 14a says, if a and b are non-zero, a dot b equals 0.
non-zero,
They're not zero. A dot b equals 0 if a is perpendicular to b. Okay, so what we're going to do is we're sort of going to do, the way I looked at this one, when I did my solution here, was I sort of did like a left side, right side proof. Okay, if I'm going to say a is equal to ax, ay, and b is going to be bx, by. Okay, we're okay on that original thing? Okay, can someone other than Derek tell me then what A dot B equals, please, from yesterday? No, not yet. I'm going to do Spider-Man today, okay? So who wants to go first? This is the easiest question of the day, so take it now, please. Brennan, go ahead.
AX times BX and AY times BY.
Very good. So on the left-hand side, we have AX, BX plus AY, BY equals 0. This is sort of the left-hand side. So this is going from here to here. Okay? All right, I'm going to rearrange a little bit. What does AX, BX equal?
Negative AY.
Very good. Okay. So therefore, AX, BX equals negative AY, BY. So I'm just going to leave it like that, and hopefully we can get the right-hand side to turn into that. Now what the right-hand side would be, it says A is perpendicular to B. If A and B are perpendicular, what does that mean if A and B are perpendicular? This is a trick. This is a trick to this question. You got to keep your mind open. Go ahead. Good. The slopes. So if A and B are perpendicular, their slopes are negative reciprocals. Now, are you ready to have your mind blown by reciprocals? You ready to have your mind blown? Here it comes right now. What does slope equal in English, please? Back in grade 9.
So, like y equals mx plus 3, rise over run.
Rise over run. What's another way you could say rise over run? Close, but what's another way you could say rise? What's rise on the graph? Rise is going to be your?
How, like the y?
Good. Okay. So I'm going to say for my A, we're going to have AY divided by AX equal A slope. Are we okay on that logic there, what I did there? Like rise over run. Okay, now we said that B's slope has to be the negative reciprocal. Oh my goodness, Callan. How would I get the negative reciprocal of that? Any idea?
AY over
Yeah, what's the negative reciprocal of that going to be? No? It's okay, it's all right, it's okay. Yeah, go ahead, Teresa. Just use it AX over AY? Close. Negative AX over AY. So therefore, B's slope So what I'm going to say then is I'm just going to solve the equation then. So AY over AX has to be negative BX over BY. Okay, because their slopes have to be the same then. Okay, the perpendicular slopes. So then we get AY BY equals negative AX BX, which is equal to negative AY BY equals AX BX. So this one was a tricky one. This for sure was the messiest one we had to do last night. Okay. But you have to say their slopes were the same. If their slopes are perpendicular, which we're told, okay, then A dot B equals 0. So on the left-hand side, we proved that A dot B equals 0. What happened for that? On the right-hand side, we were given that the slopes were perpendicular. Therefore, the slope of A is equal to the inverted slope of B, right? And then you just solve, you make both sides be the same. Bailey, how you doing? Good? Yeah. Did you get your homework done last night, by the way?
Yeah.
I don't see yellow shoes on. I don't, then the rest of the class knows that already. Okay, does that make a little bit of sense there, right? You have the original slopes, the perpendicular slopes of them equal solved, and then that's the left side, right side. I'm going to do another one too, either B or C. Sorry. Oh, 13 is, I think you just used an example. So, okay, so for 13, what happened, guys, for 13, you'd actually pick numbers here. You'd pick numbers like 4 and 6 and 2 and 3. For 14, then it's a general case. Do you guys want me to do B or C? And then we'll stop. Does it matter? 14A, that was 14A.
I think it's 14, isn't it?
Yeah, so we do the whole thing? Oh boy, here we go. Want me to keep going?
Is there B and C?
Yeah, there's,
Well, no, because 14 is.
do you want me to keep going, or is that
Oh,
enough?
never mind, this is.
Do you want me to keep going?
Just the last.
Alright, one more, then we're gonna stop. 14B says, prove that, sorry. A dot B equals B dot A. Okay, this one should be easy. Brad, what does A equal in general, what does B equal in general, please? See, I wrote that down. I'm just gonna look at monkey up here. Just write whatever you guys said. BX, BY, thank you. Okay. Teresa, you raise your hand 5 times saying that, thank you. Can you tell me what A dot B equals, please?
Is it AX plus XY?
Okay. Austin, can you tell me what B dot A equals, please? Okay. Are those two things the same?
No.
Yes.
Of course they're the same, right? You're just gonna multiply. No, it's therefore, so then we can just write this as. I'm not gonna do any more for, and that's all there is. Like, people freak out when they see proof, but that's all that one was, and C is easy like that too. Okay, right? A was the only trick one, that's why I wanted to do it from that, okay? I'm gonna pause the video, take a break, and then we're gonna start today's lesson, okay? All right. Today, if you're curious, it's called Application of Dot Product. That's the title it's going to be.